Yeah, I think one point that I got from this session was really how different drivers can be for different planets and different stars. So you can have different contributions from UV, from the solar wind, and from energetic particles, and then going into details. For example, UV can be changed by dust storms and so on. So I think it's very nice to try and connect, as was done in this session, the study of our solar system and exoplanets. So I don't know if anyone has further thoughts on this or anything else brought up during the session.
We have a raised hand, Alex.
Yeah,
Yes,
so I guess, you know, I was very interested to see all these characterizations of energy input coming from the host star. And one thing that I think is very interesting that, you know, I didn't see as much on, although a little bit, is how the magnetic field will regulate that energy input into the atmosphere and what role that plays. That, you know, it's not enough to have the higher energy input, but, you know, how efficiently does it get transferred into the atmosphere, and in what form does that energy transfer take place, and how does the magnetic field affect that? I think that's something that's very interesting, and you know, I think it'll be nice to see, you know, further work on this.
Go ahead, Vlad.
Yeah, I want to compliment the Alex. Yeah, you're absolutely correct. Of course, the coupling is probably this comes to the point of coupling, right? So how the stellar output couples to the planetary magnetosphere or to the planetary atmosphere through this variety of effects, and that's basically what differs, you know, the atmospheric escape from the current terrestrial planets, from current Earth, Mars, and Venus, from exoplanets. So, and would be very interesting to see that, you know, how we can expand this, if it's possible to expand any couplings from the solar system to exoplanetary environments. I think that's probably many orders of magnitude different, right? So, if anybody wanna discuss that.
William, you've got your hand up.
Yeah, observationally at Earth, when the magnetic field is southward, when the magnetic field lines are aligned and reconnection are not aligned and reconnection occurs, ion outflow maximizes, and it basically shuts off when the stellar and the planetary magnetic field are aligned. So the way you get around that is you assume that the magnetic field orientation of the sun varies as it does on Earth. But if the magnetic field of a star were to stay in one direction, then ion outflow coupling would be strongly affected. So yes, the relative orientation of the stellar magnetic field and the planetary magnetic field matters a lot.
Eric, you've got something to say?
Yes, yeah, it's important to keep in mind that the magnetic field is going to affect what happens with the ions, but of course, some of the speakers are dealing with neutral atmosphere escape, and for that, magnetic field is practically irrelevant. Where the magnetic field does come into play is when you're talking about the precipitation of energetic particles from the stellar wind into the planet. On a magnetized planet, that's going to be concentrated in two locations, the magnetic cusps. And the situation with the sun and the Earth is that the particles that come into the cusp from the solar wind tend to be a few hundred EV, and that is a sweet spot because that penetrates to the depth where you have enough of an ion fraction to start energeting the ions and have them decouple from the neutrals, where more energetic particles penetrate more deeply, and the ion neutral collision rate is too high for them to do much in terms of ion outflow. Of course, if you're generally heating the upper atmosphere enough, that can contribute to escape in situations that are not Earth. But on Earth, the energetic electrons don't really influence the outflow.
Yeah, I think Vladimir, you had your hand up a minute ago.
Yeah, I just want to basically comment to Eric's. Yeah, it's a very good point, Eric, that you mentioned. But I think that energetic particles, can change the whole dynamics through the change of chemistry, and the chemistry will eventually, affect the efficiency of cooling rates, right? And which will moderate the atmospheric escape. So that's a little bit complicated, which needs to be studied, of course. But for Earth, this is not probably an issue because the electron fluxes are pretty low to make a big difference on chemistry.
Edel, would you like to go ahead?
Sure. Just following Eric Lund's comments on the magnetic field and the neutral escape, I think the hypothesis here is that the magnetic field plays an important role not only for the ionosphere, but also for the neutral atmosphere and escape of neutral species. And this can be based on two aspects, among others. The first one is the magnetic field controls the ion flow, influences the ion flow, and the ions and neutrals are coupled, for example, via ion drag or neutral drag, looking at, depending on which direction you're looking at, whose influence on what. And that will influence circulation in the upper atmosphere. And then there's a Joule heating factor that other speakers have repeatedly emphasized. So the magnetic field indirectly influences neutral flow and neutral energy budget, probably to a significant degree, depending on the configuration of the magnetic field and intensity of the magnetic field. The second aspect I think that should be mentioned here is the influence of the magnetic field on small scale variability like waves, atmospheric waves, specifically gravity waves, because as I was trying to communicate in my talk, probably unsuccessfully, is that the propagation and dissipation of atmospheric waves in the thermosphere and ionosphere depend on the direction, relative direction of the magnetic field with respect to the propagation direction of the waves. And propagation direction of the waves is influenced by the neutral atmosphere only. But if you have a strong magnetic field environment, that would modulate, the dissipation of waves would be modulated by the orientation of the magnetic field, and eventually how much energy is deposited into the mean flow by waves would be influenced by the magnetic field in an indirect way. And we have learned that Jeans escape is an important escape process in which waves can contribute. So magnetic field orientation of the magnetic field in a planet can modulate wave propagation and dissipation and wave fluctuations, which goes into Jeans escape, probably among other escape processes.
I'll chime in here and offer that, you know, for me, most of the presentations today have highlighted that, you know, it's more complicated than we think, that, you know, there are lots of things that need to be considered if you want to get the answer right. And what I'm still having trouble wrapping my head around is which of these things are order of magnitude important, and which of these things are factor of 2 important, and which of these things are sort of 30% important in terms of escape rates or atmospheric evolution. And so that's a place where I'm still trying to place everything in context.
So on that note, does anyone want to add anything that they think is going to make an order of magnitude difference to these kind of calculations? I can see that in the chat there's a comment. At Earth, there is a question about Joule heating contributions to heating the thermosphere compared with the superthermal electron precipitation heating effects. Different models give different answers, it seems. Does anyone have any thoughts on this? You can see a hand raised. Yes, Offer?
Well, I just want to follow on Dave's comment. I think the problem is that we are trying to look at different processes, where, in a matter of fact, in a real planet, many processes will operate together. And sometimes one process will dominate, and sometimes other process will dominate on timescales that may be a timescale of a CME's pathing around the planet within hours, or just the solar wind conditions are changing from one thing to another. So I think the main challenge is that in order to really understand this problem, we really need to consider the coupled system like physics that involve many processes together. And that's what makes it so complicated.
Yeah, I agree. And I wasn't trying to necessarily say that order of magnitude things are the only ones we need to be considering. I think depending upon what question we ask, that sets, what needs to be fully considered. And then there, as you mentioned, Ofer, there are all these feedbacks between things that make it much more complicated. It could be that processes that make a 30% difference in an escape rates are important in the long run, depending upon what you want to consider. If those processes influence trace gases that are important for habitability, for example, then they can't be ignored.
Thomas, go ahead.
A big difference between the exoplanets and the solar system planets, to sort of state the obvious, are models which are pulling all this together that people are talking about are highly constrained by lots of observations, and that these observations make a number of the choices for us, what are important, what are not important. The real issue going over to exoplanets then is data availability, and where is that going to go in the next couple decades?
Also, we never followed up on Laura's question in the chat, so I don't know who our Joule heating experts are here.
We also have a raised hand there, Bill
That
Peterson.
would be for Sukbin or Alex, I guess. but maybe Will can refer to that.
I was going to respond to Tom Craven's comment about things being data driven. Perhaps those of us that are observers can go over the exoplanet presentations and see if we can find things that exoplanet people can do and stretch them, and see if we can ask what kind of additional or new observations we want from exoplanets. I think that's a important contribution that we can bring a new set of eyes with our observing tools at the Earth and see if we can't encourage our astrophysical comrades to make a different type of observation.
So I guess I agree with what Bill said, but I wanted to follow up with this question in the chat about Joule heating versus electron precipitation, and I think part of the point is that they're linked to some degree, because the precipitation will change the conductivity, and the conductivity will change the electrodynamic coupling between, the magnetosphere of the planet and the atmosphere. And so it will in effect regulate the energy transfer through the Joule heating. So, they're different in some ways in that, the direct, heating and other ionization, other effects of the precipitation is one aspect, but the change in the conductivity and the impact of that on the convection in the topside ionosphere and the heating in the ionosphere, are different things, but related. So I'm not sure if that actually answers the question, but maybe helps clarify a little bit.
Julian, have you got something to add?
Yeah, well, not directly related with that last point, but maybe mostly from kind of this observational point that was made in terms of what in principle can be observed, or cannot be observed. And I think it really boils down to what of the communities you're talking to, right? If you want to really understand this process of atmospheric loss and the influence from magnetism, planetary magnetization specifically, I mean, this is a question that it will be answered by the solar system community. Right? This is not a question that will be answered by exoplanet community, because there's absolutely no way in exoplanets we're going to get better measurements than what you can get on the solar system. But on the other hand, if you're interested into the extensions of this question into things like habitability, life elsewhere in the universe, and broadening the parameter space, then this is a question for the exoplanet community. And this is precisely what I think I believe Judy was trying to make the point in their presentation in making sure that for the people in both communities, you realize the strong differences when you're dealing with the type of data available for both communities. For the sun, you have observations 24/7, pretty much, several satellites. You have way too much data, actually. So, I mean, so it's probably more data that you can handle, I would actually say it. But on stars, the situation is completely reversed. And actually, there's no monitoring. There is no dedicated mission to observe the kind of things you would like to observe. If you're trying to understand the atmospheric history or the atmospheric conditions of an exoplanet, this is impossible to do if you don't know in what kind of environment the exoplanet lives, what kind of star this exoplanet is orbiting, how active is the star, what is the X-ray flux, does it have a cycle, does it have flares, does it have coronal mass ejection? So all of those questions are impossible to answer if you simply don't have the observational capabilities. So I think it's really important to understand really the differences from which community comes from. And when you do a criticism, you need to be aware of this, right? I mean, this is the first thing you need to do.
We have a comment in the chat saying people are definitely working on gathering those data. So I think, yeah, that there's agreement that this is an important point. So I think we're coming up to just after 1:30 now. So I think we're going to wrap the session up. Is that right, David? Dave, sorry.
Yeah, that's fine. Dave or David is fine. I answer to either one, but most people end up just calling me Dave. First of all, yeah, thanks a lot, Laura, and Mats for hosting that session. And thanks to all of the speakers, both in the most recent session and earlier today. We'll be back tomorrow, starting at the same time that we did today, which is 7 a.m. Mountain Daylight Time here in the US. And the session tomorrow, the oral session tomorrow will be ion outflow and escape, with Alex Glosser giving an overview talk, and then contributed talks by Hans Nilsson, Chuanfei Dong, Narutoshi Kitamura, Nilafar Naruzi, and Leonardo Regoli. And then following that, we'll have the poster session tomorrow. We'll be sending out email about how to access that poster session and interface with the spatial chat platform. And we'll also be posting that in the Zoom chat or Slack tomorrow. So with that, anything else from you, Laura or Mats, or anyone else?
Nothing more from me. Thanks to all the speakers and everyone. It's been really interesting.
Okay. Thanks a lot, everybody. See you tomorrow.